So today I will applying the concepts studied in my TOK class in the field of natural science. So lately I came across an article talking about how in 1831 Faraday discovered the electromagnetic induction, and in 1832 Joseph Henry, an American scientist, discovered the same principle independently of Faraday's work. So the electromagnetic induction is the process of generating electricity using magnetism. And when I came across this finding, this situation really intrigued me, and it raised different questions in my mind, ranging from how many possible methods can lead to a particular truth. How much does the scientific approach affect the journey to the discovery of scientific findings, and why would scientists use different methods in the pursuit of a common objectives? All those questions were mixing into my mind, and as I was trying to get a better understanding of my real life situation, things started to get more complicated. Therefore, I shaped these three questions into one question that could help me explore these real life situations with the TOK concept that I acquired. And my knowledge question is, how does the educational background of scientists affect the scientific method they use? First and foremost, before diving into the presentation, we need to restrict what we mean by educational background. So the knowledge someone acquires from the educational background could range from a lot of things, as for instance, informal knowledge, experiential knowledge, academic knowledge, or practical knowledge. But for this particular presentation, we would narrow the knowledge considered within the educational background as academic knowledge, which is the knowledge acquired from the academic subject learned at school, or the knowledge acquired from libraries and other source of knowledge. And also we would focus on the experiential knowledge, which is the knowledge someone acquired from doing something. My knowledge question is connected to my real life situation, because first of all, Michael Faraday was born in England, and he was a self-educated scientist. He never attended a university. However, he learned science through the various books that he read, and through one of the most famous chemists at the time, whose name is Humphrey Davy. And Faraday had the opportunity to learn about metallurgy, and how cutting the line of a magnet could actually have some interference. Cutting the line of electric wire could have some interference, some magnetic interference around. And the method he used to discover the electromagnetic induction was based on moving copper relative to a permanent magnet. Then he used what he learned through the metallurgy session that he had with Humphrey Davy in order to come up with his scientific method. And Joseph Henry, on the other hand, was born in the United States. He studied engineering at the Albany Academy, and he had a lot of knowledge, background knowledge in electromagnets, because he built several of them, especially in 1820, when he built a huge magnet for Yale University. And he used the scientific method that he used to come up with the electromagnetic induction was based on using electricity to create a powerful electromagnet, which thereafter would induce current in another one. So this is show how the real life situation is actually connected to the knowledge question, because the educational background of those two scientists affected their method. And the first approach to this is that the scientific method can be based on the set of knowledge from the educational background of the scientist. That means scientists would use memory, which is the process by which you go back to already stored knowledge in order to acquire new knowledge. So memory would be used as a primary way of knowing for those scientists, and they would be basing what their method on what they already know, and that could range from academic knowledge and experiential knowledge. And one example of that would be the black box experiment in our TOK class, in which we had to discover what was inside this black box, and there was a rolling object. Some students who had knowledge in physics, they used a magnet to see whether the object was magnetic or not. But some other students involving in other fields, they try to listen or they try to do some other method in order to see whether the ball was magnetic or not. And it's a clear example how the method they use was based on what they already know. On the other hand, there is another approach where the scientific method could be contradictory. It could be used to refute the set of knowledge that students already, the scientists already have. And in here, science itself as an area of knowledge would be used, and as science is the ultimate seek of truth, then people would be driven by the desire to question what they know in order to have a better understanding of the world. And as a matter of fact, in 1662, Boyle's experiment of the gas law was completely contradictory to what he already know as about science, because he evolved in the time of alchemists who believed that there were only 4 elements, and that they were pursuing the philosopher's stone, which would allow them to get immortality. And Boyle's method was kind of contradictory to this set of method, as later in his life he discovered Galileo's work, and he thought that the world could be explained using mathematics, and therefore his method was kind of show a clean shift from the method that he learned from the one he designed, which was contradictory to the secrets of the alchemist. And one last approach to this knowledge question would be that intuitive scientific method can be verified by the knowledge acquired from the educational background. And in the history of science, different scientists have come up with revolutionary concepts only on the tip of their head. That means they didn't use an actual scientific method, but their findings were based on inductive reasoning, where their conclusions could have been were probable. However, they stated it, and thereafter they would use knowledge they already had in order to prove what they stated. And as a matter of fact, Newton in 1687, he came up with the gravitational law only through reasoning and observations, and he afterward used calculus in order to verify this finding. And in conclusion, those arguments allowed me at least to understand my real life situations better, because I could see that there is not a fixed toolkit as in science, in scientific method. It is not defined as something specific. However, it can be influenced by various factors, including the educational background. Faraday's and Henry could be using different methods in order to come up with the same thing, as they did not have the same level of education and the same background. And these findings could be all applied in other situations, such as art, where artists could be depicting the same thing using different techniques, as the techniques could be influenced by their educational background or the environment in which they've been evolving. And in politics as well, where politicians are elaborating similar laws and with independently with each other. And at last, in teaching methods, it would be relevant because different teachers would have different approaches to the same concepts and within their careers. So thank you very much for following.